You know what you have to do to distribute a Java program. First, you've got to make sure the Java runtime environment of the proper version is installed on the target machine. And second, you've got a collection of class files that make up the executable program, and they all need to be copied to the system. Usually, a directory has to be created to hold them. Third, you have some data files, images, configuration settings, whatever, to be copied to the system. They can usually go into the same directory as the class files. Finally, you have to come up with some way for the command to be entered that will run the program. I can show you how all the class files and data files can be packed into a single file, and installing that one file on the target machine will install the application. You can pack all the files into a single jar file, and the installed version of Java can run them right from the jar. In fact, the Java system runtime files are deployed this way when Java is installed, so some of your class files are already being run this way. You can electronically sign a jar file so it can be detected if it has been diddled with. Also, another advantage of deploying your application this way is the file size. Anything placed in a jar file is compressed. It's no secret that the jar file is in the zip file format. You can actually use the standard zip and unzip on jar files. The thing that makes jar files something special is some special content. It's best to use the Java utilities to work with jar files because they know about this special content. The jar tool is a program you can use to construct jar files, view the contents of jar files, and extract contents from jar files. Let me show you how to make a jar file. This is the main class of an application to be packed into a jar file. It refers to three other classes. Each of these other classes has a static method named getName, and that method returns a simple string. This program just displays the string from each of the classes. Whenever you use the jar tool to construct a jar file, it automatically builds a manifest file containing some Java version information. But you have to add something to it. As you know, every Java class can have its own main method, so it's necessary to specify the name of the Java class you want to use as the main line of your application. To do that, you make up a text file with the name of the class in it. This one shows the class name Rivers is the one to be executed when you execute this jar file. Notice that the name of the class appears without the .class file name suffix. One other thing I need to mention. You must put a carriage return at the end of this line of text. If you don't, the jar tool just won't see it. With all the classes compiled, this command can be used to build a jar file. Now, if you're familiar with the Unix tar command, the form of the command line will be familiar to you. This first letter, the C, is the command to create a jar file. The next letter is an F, which means the very next thing on the command line is the name of the jar file. The M means that the next name on the command line is the name of the file holding the text you want to add to the manifest. Following that, at the end, is the list of files that you want to insert into the jar. There. That builds the jar file. And you can run it this way. You can see that Java looked in the jar file, read the manifest to figure out which class to execute, found the main method in it, and ran it. In the next lesson, I will show you some other things you can do with a jar file. In the previous lesson, I glossed over some jar file creation information. I'm sure you noticed the presence of the asterisk as a wildcard on the command line. This command includes all the class files in the current directory. You could just as well have named all the class files this way. It's not uncommon to place data files in a subdirectory. The jar file has its own directory structure, and you can use it to organize things. This command not only includes all the class files in the current directory, it includes the directories named images and data. Naming a directory on the command line includes that directory and all the files that are in it. If you want, you can just use a single asterisk and the jar file will include all the files and all the directories. Inside your program, you handle references to files in a directory the same way you would handle files and directories in a regular file system. You can have the jar command pull files out of a directory and put them where you want them in the jar file. The C option, used twice in this command line, will pull all the files out of the named directories and put them in the directory specified. In this example, a dot is used to specify that the target directory is the main directory. By default, all files are compressed when they are put into a jar file, but you may want to leave them uncompressed if you have plenty of room, and uncompressed files may load a little faster. To prevent compression, just add a 0 to the set of flags on the command line. The T option lists the contents of a jar file. The F option means the same as it did before. The next name on the command line is the jar file. The first thing listed is the manifest file. It always has the same name and is in the same directory. This jar file contains two directories, data and images, and there are files in both of them. And it has some class files in the main directory. By the way, the path names are always shown with regular slashes, regardless of the operating system. The only option when displaying jar contents is the V for verbose. It shows the timestamp information of each of the files. You saw earlier how to modify the manifest by specifying the class to be used as the entry point for your application. You can also use it to add jar files to the class path. This manifest update file adds 2 lines to the manifest file. It specifies the entry point as we saw earlier, and it also enhances the class path. When this jar file executes, all the classes stored in the burners jar file are added to those on the class path. Coming up next is one more lesson on jar files. I'll show you how to add a signature to your jar file and how you can verify that signature. You can sign a jar file with an electronic signature, and whoever runs the jar file can verify the signature before granting permissions to the software that might otherwise be prohibited. To sign a jar file, you use a private key value. Only the person in possession of that private key can sign in such a way that it can be read only by using a specific public key. A reader of the file can use the public key to verify that none of the files have changed inside the jar. The only other possible question is the ownership of the private and public keys, and that is handled by the reader acquiring the public key from a certificate registry. Now, I won't go into the registry information here. I just want to show you the keying of a jar file. The information needed to sign a jar file is kept in a local file known as the key store. Inside the key store, a specific key pair is identified by an alias name. A key store can hold more than one pair of keys, so when you refer to a key, you need to name both the key store and the alias. To sign jar files, your first job is to get a certificate, a key pair. There are 2 ways to do it. You can get one from a certificate authority, or you can just create your own. It's considered better to get one from a verifying authority because the person reading the public key can then verify through the third party that you are who you say you are. A program named KeyTool stores the keys in a key store. You can use the key tool to import keys sent to you by a certifying authority, but for this example, I'm just going to let KeyTool build a key and then create a key store to hold it. Now, the KeyTool utility has been redesigned for Java 6, so even if you're familiar with it, you need to check it out before you try to use it. The gen_key_pair command of KeyTool will generate a new key. There are lots of options that you can use. This command doesn't use all the available options. It just lets KeyTool prompt for what it needs. The password must be at least 6 characters in length. This password also must be at least 6 characters long. There, the key store has been constructed. With the key store constructed, the signing of the jar file can commence. It's done with a program named jar signer. The only items required on the command line are the names of the jar file and the alias name. The name of the key store is from the previous step. The name of the key store will be the default name unless you specify otherwise, as in this example. Other things could have been included on the command line, but doing it this way will cause the command to prompt for the passwords. It will overwrite the existing jar file with one with new files in the same directory as the manifest file. A new version of the jar file has overwritten the old version. The new version is signed. Whenever the jar file is run, it is verified. The verification is done automatically. The Java virtual machine does it when you execute the jar file. If the jar file holds an applet, the web browser verifies the jar file when it loads the applet. But you can check the verification of a jar file by using the jar signer. This simple command tests the signature of the jar file. Now, 3 outcomes are possible. If the jar file is not signed, the program will tell you so. If it is signed but the certificate is not valid, it will tell you that. If everything is okay, it will tell you that the jar is verified. If the contents of the jar file had been modified after it had been signed, it would have told you that and refused to verify the jar file. You can also run this command with the verbose option to get more information on the keys and certificates. In the next lesson, I will show you how a Java web start is constructed. A full-featured application can be run on a machine that does not have the Java runtime installed. You can simplify the steps required to download and run a Java application to that of a single mouse click on a web link. Now, this is not an applet. This is the installation and running of an application. Let me show you how. You can get a web start application ready to go in 5 steps. Now, notice I didn't say 5 easy steps. I mean 5 reasonable steps. Step 1. Web servers all know how to handle MIME types, but you'll need to check on what you need to do to set yours up for a new MIME type. It's really nothing more than defining a new MIME type in the server. Exactly how you do it depends on which server you're using. Now, the most common server is Apache. The hosting of my website is done with Apache, and to add the new JNLP MIME type, it was a matter of adding this one line. This means that the files with a .jnlp extension will be sent to the browser as this type. In turn, the browser will cause WebStart to execute. The second step is to create a jar file that holds the application. You saw how to do that in the previous lessons. For this example, I modified one of the examples from an earlier lesson. It uses the System Color Selection dialog. I named the application and the jar Color Picker. Any application that you can run directly from a jar file can be downloaded and run by Web Start. This is the command that will build the jar file. You saw the details of doing this in the previous lessons. Step 3 is the creation of a JNLP file. JNLP stands for Java Network Launching Protocol. It's a text file with all the instructions and definitions in it. This is the JNLP file for Color Picker. As you can see, it's an XML file with the standard XML header. This is the main element of the JNLP file. And this is the version number of JNLP. The plus sign indicates that this is the minimum version number. Greater versions can be used. This is the name of the directory and the name of the JNLP file. These description tags are pretty much free-form and self-explanatory, except this last one. This one indicates that the application will run just fine with the computer not connected to the internet. This is the name of the jar file containing the application. This is the version of Java and where it can be downloaded. And this is the name of the main class in the jar file. Even though it's in the manifest, you have to put it here too. Now this JNLP file doesn't have everything possible in it. It contains only the fundamentals needed for this demonstration. You can get a full spec, more than you'd like to know, online. You'll find a link on the web page used to demo this program, and I'll be giving you that demo here in just a minute. You need to set up a link to the JNLP file. It's simple enough. It looks like a normal link. It just names the JNLP file. It's all built. All you have to do is upload it to your website. This is the final step. Once you've done this, it's ready. The application I just showed you has been uploaded to this site. You can see the link on this page to the documentation I talked about earlier, so you can go there if you need to. Here's how it works. With this, the jar file is downloaded, and the application starts. You can disconnect from the internet completely if you wish. The program runs as a standalone application. It doesn't do much, but it does let you pick colors. In the next lesson, we're going to look at annotations. Annotation is like nothing else in Java. It was completely new in Java 5, and it's very different. This lesson introduces you to it and how it works, and you'll be seeing other aspects of it in upcoming lessons. Annotations are really a form of documentation. Now, this is not Java Doc. This is something else. The annotation documentation is in the source code, of course, but it can also be written in such a way that it appears in the runtime code also. But it doesn't do anything. It can appear in the runtime code, but it is never something that's actually executed. While annotations do not directly produce executable code, they can slightly affect the way the compiler operates, so they can have an effect on what code is produced, but it's minor. Because some annotation information can be included in the runtime code, it is possible to inspect the annotation information at runtime. Inspection is not covered in this lesson, but it is covered in a future lesson. Let's start with a simple annotation. An annotation always begins with the @ character, and it always comes immediately in front of the item being annotated. This is an annotation of a method. In this example, the annotation override is being used to document the fact that this method is overriding a method of the superclass. Because of the annotation, the compiler will check. You can see that the compile failed because the method name was misspelled and there was no such method in a superclass. Without the annotation, the error would have simply gone unnoticed. This example tries to create an instance of the vector class in its raw form, that is, without using the generic portion. Here's what happens when you try to compile this class. But you can use an annotation to suppress warning messages. This is a warning message, so it can be ignored. The class compiled OK. Here is almost the same class again, but this time the suppress warnings annotation is suppressing the emittance of unchecked warning messages. Here's what happens when you compile it this way. It's the same as if the vector class had been declared without generics. The class compiles clean either way, but this way the compiler shuts up about it. The various compilers have different warning messages, so you'll need to check the documentation of your compiler and see what warnings you might like to suppress. You can put as many as you like in a list like this, and any that don't apply to the compiler are just ignored. You can define your own annotations and apply them as you like. The keyword interface preceded by an @ sign is used to declare an annotation. You declare the annotation as a list of variables. You can use any of the Java types. The syntax for the variable name sort of looks like a function. It's followed by the keyword default and a default value for that item. I'll have some more about these declarations in a future lesson. This annotation is declared with some annotations of its own. The documented annotation means that the information from this annotation, whenever it is used, will also show up in JavaDoc. The retention annotation means that this annotation will be included in the runtime. That is, it will go into the class file. Here is an example of the newly defined annotation being used to annotate a class. When this class is compiled, the resulting class file will contain the values defined in the annotation. More about all this later. In the next lesson, we start looking into the contents of the Java lang package, and annotation is one of its sub-packages.